So here we go. Master of Computer Vision program launched by the HEC University welcomes you at today's meeting devoted to modern tasks of Computer Vision 2022. My name is Alina Labanina. I am head of the study office of this program. And today we have special guest, Olga Razvenskaya. Yes?
Yes.
Senior research engineer at Huawei company. And today she presents our most important industrial partner of our program, actually Huawei company. So Olga, hello.
Hello.
Welcome and thank you for joining us today. And to begin with, just a couple of words about your career. So what are you focused on at your work and what is your professional interest at Huawei?
Okay. My focus of my work is the graph theory, neural networks, performance optimization, C++ programming, and many things in this field. But I know something about computer vision, and our team is working on computer vision tasks. So I'm happy to show you some very interesting cases from computer vision to encourage you to join this course, this
Okay. Just a
program.
short reminder before you start for our audience that as usual, this recording will be this video will be recorded and as usual aired on our YouTube channel, which you can watch at your appropriate and comfortable time later. So Olga, you're welcome.
Okay, great. Let me start. So, hello again. I'm a senior research engineer at Huawei in a Nizhny Novgorod Research Center, and I want to share with you my presentation about computer vision problem zoo, which means the high variety of problems of which we are working in a computer vision field. So let's start from the basic term. What is computer vision? Computer vision has a dual goal. The first one is as from the biological science point of view, it means that that computer vision aims to come up with computational models of the human visual system. From the engineering point of view, the computer vision task tries to create the models which will behave and solve the tasks which we are usually solved by our visions, our eyes, our vision system. So it is very interesting tasks, and it is so the vision is a very important sense of human. So it is very important to try to create these models. So there is a lot of application fields which I will cover in some words in my presentation, and this is the list of the topics which I will cover, and there are a lot of many more topics exists. So let's start. First of all, the most famous task in computer vision is an image classification. When the problem is that we have a picture and we want to define what object is pictured on this picture. I mean, if we have a photo of a cat, our model have to say to us that it is a cat or a dog or a mug or a hat or something else, or probably it is a house. It means we want to define which object we have to name it in this task. The next point for image classification, it is its difficulties. When we have some issues on our picture, for example, viewpoint variation, illumination conditions, scale variation, deformations, occlusions, background clutter, or probably many other things, our prediction can vary a lot. So it is very important to solve these complex issues and work with it to give a user a proper prediction. Image classification, the main data set which relates to this problem is ImageNet. This dataset contains more than 14 millions of annotated images, and it is, I think, the main dataset for this task. And you can see the progress of scientific research in this field, how the top one accuracy increases year by year. Now we have more than 91% of top one accuracy. It is a very high level of accuracy, and it is a big progress for computer vision. The next problem which we are working in a computer vision is semantic segmentation. When we have to work with our picture and split it on the fields which relates to some object, we have to label every pixel with some label which means something meaningful. I mean, here we split our images on the fields when we have a cat, when we have a grass or other objects in on a picture. Semantic segmentation this problem can be solved with neural networks, and this is the high overview picture of the neural network that solves this problem. I won't dive into details of implementation. Also, you can see here the numbers. It means the references which we will be taken on the last slides. So we have our input picture. We have to downsampling it. After that, we did some convolution layers. After that, we sample it in some method. And after that, we have a prediction which labels every pixel on the picture as some class. So this is results of mask RCNN model, and it is referred for this paper. And this neural network can label picture and can find the object and segment it from the picture of people, of motorcycles, of different objects. It means that it can split the picture on background and some other objects. It is a very good result, you can see on the slide. Next task for computer vision is and image recognition is object detection. Object detection can be in the current state. There are two ways to solve this problem. First is one-stage detector, and the second one is two-stage detector. Object detection is the problem when we have to put the objects from the picture into bounding box and label this bounding box with some meaningful value. I mean, you can see on this picture bounding box with bicycle, bags, buildings, humans, and many other objects. This is some details of how one-stage detectors and two-stage detectors differs from another, but only I want to say here that one-stage detectors is in most of the cases are faster than two-stage detectors, but not so. They have not so good precision as two-stage detectors. Next point. This is another example of object detection. We have to find the cars on the picture, and you can see the bounding box and the confidence levels of that car in this bounding box exist. And also here is the list of main two-stage and one-stage object detection methods and algorithms. Here, the very common picture when I have to here I have to split in your understanding the differences between image classification, object detection, and semantic or instance segmentation. And all these terms are located under the hood of the term of image recognition, but you can see here that they are all different tasks and they solve the different problem. The simplest one is classification. We just want to name the cat. And the models from the right side are more complex, but they are different and they are used in different cases. Next, next slide is about image generation. There is a very cutting-edge technology. You can see two examples of image generation neural networks, Imagen and DALI 2. DALI 2 released in this May. It is very fresh results, and they are so excited. So they are so exciting for me. So I decided to show you the main scheme, how it works, and the main wonderful result. First of all, what is the image generation task? Image generation task means that we have a sentence, words, which explain in words what kind of image we want to get from neural network. For example, we only have a sentence: a golden retriever dog wearing a blue checkered beret and a red dotted turtleneck. And you can see the generated image from this sentence. For me, it's wonderful. Here is the two another example. Left one is from DALI 2 and the right one is from Imagen. In the bottom of the slide, you can see the text description of the task which neural network got, and the images are the created results from this neural network. Also, this image generation task can extend the current the image in some way. Now you can see the famous picture of Valentin Serov, Girl with Pictures, and further I will show you how DALI 2 neural network model generate the environment outside of this girl. Let's see the video. It will be some slides of what the neural network model return on for this task. You can see that neural network is quite creative and can pick a style of an artist, and you can see it is very, very interesting case. Just repeating of this wonderful video. Also, you can see the link. The last slide will contain the source of this image. Great. Next point is when we can use computer vision and related topics to computer vision is data augmentation. Data augmentation is used when we have not so many not so many elements in our data set. For example, we only have 1,000 of pictures, but we need many, many more ones to train our network, and we have to enrich our data set with more examples, which will differ one from another one, but still will have a sense. So it is also, this method helps us, it can be used as kind of regularization of machine learning model, and it helps to avoid overfitting. So there are two main approaches for data augmentation and in computer vision at all. First is based on deep learning methods, and another one, it is called as classical algorithms, which not related to neural networks at all. So here you can see the results of classical enrichment of data set. So the next slide will I will show you the neural network based augmentation method. You can see neural style transfer. It grabs a texture, ambience, appearance of one image and mixes it with the content of another. You can see on the left column the original photos for some cities, for example. The middle column shows us the reference photo of the style, which means, for example, for the upper image in the middle column, we can see the sunset, and on the right column we see the city from the left column in a sunset style. And here more examples. It is very impressive for me to see these pictures, how it works in real life, how we can enrich our dataset with neural networks, and after this enrichment we can train our machine learning models in a more efficient way. Next application of computer vision is so-called super resolution task. Super resolution is the task of taking an input of a low resolution and upscaling it to that of a high resolution. This is a picture from some article, which is referred in the last slide too. We can see the original photo of a small boy, and before it was upscaled, before it was upscaled, it was its dimension will be divided by 4. I mean, these pictures, the second, third, fourth, and fifth, was got from the just 1/16 of this ground truth picture. So you understand that the ground truth, that the input picture was so small, so you can get the small details from it, and you can see that bicubic um, bicubic method. It is a classical method which is based on spline interpolation. You can see here that it is some kind of blurred, but the modern methods of super resolution gives us a picture with a very high resolution and with very good quality. The next point when we can use computer vision is the anomaly detection task. Anomaly detection is a very important task in industry and in many other cases, but for example, this is really used in real life when we have some details and when we put the camera on some industry line, and this camera looks on the objects and can find some anomalies. For example, you can see here some um, good examples. Later you can see some damaged examples, some examples with anomalies. And the lower line shows these anomalies in a higher scale. So it is very important to have these methods to have an anomaly detection, to decrease the number of the bad samples from some industry line, for example. And here the very high level scheme of patch core method for anomaly detection, and you can see that output of these models are like a heat map. When we have for example, the high temperature in the places when we have some anomalies. So our data set was trained on normal samples, and on the testing stage we have a sample with some anomaly, and you can see here this nut is broken. So on this heat map we can see where is this anomaly is placed, and it is very important to see it online. Another case of using of computer vision in real life here, I think it's our near future when we will have autonomous driving cars, and there is many places for computer vision in this field. For example, here the real life video when one man go from a Super Bowl match on a autonomous driving car, and it shows us how many people's this car seeing and highlight, and how it works with a lot of cars around it, and how it track all people's outside the car. So let's play the video. You can see that in the night our eyes can see so many details and can track so many objects. So here we can see that computer vision task in this field works very well. so many people. Car is tracking. It built the track. So I think it is our new future. Next point, next example of computer vision task is 3D modeling from the depth camera. You can see on the left side of the picture the output of the special depth camera, and on the right side is the 3D model based on this data, which was built by classical algorithm. There is no deep learning here, just classical algorithm. So you can have a depth map, and you can render after that the 3D picture of the space. Also, there are a lot of many other topics in which computer vision shows some good examples. For example, 2D human pose estimation, 3D face animation, facial recognition. Also, these, for example, Face ID is based on the 3D facial recognition task. Depth estimation, optical character recognition, which means when we have some picture with symbols and our algorithm, it can be also it can also have a classical nature. This algorithm can understand what the symbols are placed on the picture and write out the text which is which this picture has. Also, medical image segmentation wasn't covered in my presentation, but it is also a very important part. Now, after the COVID-19 pandemic, we have a lot of data about CT scans and other picture of human lungs. Also, there are a lot of papers that try to understand how cancer can be placed in the human body, and there are a lot of places to work with computer vision in a medical segment too. Also, another computer vision task is video classification and scene parsing, and it is also not the end of the list. There are a lot of applications of computer vision, and I think it is a very interesting field to research and to understand how it really works, how it can be improved, and what the real practical example and applications, and how computer vision can improve the quality of our lives. So this is the end of my presentation. This is the references. I will show you the main links that I used to prepare this presentation. So I would like to thank you for your attention.
Okay. Do you hear me?
Yes, I
Okay,
hear you.
dear Olga, thank you for joining us, and thank you for such amazing presentation, because you provided information so clear for understanding, even for me, who is far, far away from IT industry and who is just watching this like a beautiful, interesting movie about future, especially about car. And speaking about medicine segmentation, you have already mentioned it, and I'd like to mention that we have current group who has started our study last year, and so they have 2 years of study, and second one, the next will be the last year of their master degree, and one of our students is planning to base his final thesis research, especially on medical segmentation, especially on medical segmentation. So it's really very interesting.
Yes, and the scientific community is working hard on this field, and it is very important field too. There are a lot of publication about computer vision in medicine, and I think it is a very important task too.
Yes, moreover, I've read an article that we expect a huge amount of different pandemic in our life, not only COVID. So I think that medicine segmentation will be very, very useful. Now, if there are no questions, I am going to share my short part of presentation, especially a couple of words for our applicants, what they should do next if they want to apply to our program. I'm going to share my presentation. It takes about a couple of minutes. So do you see my screen with presentation?
Yes.
Nice. Um, yeah, about like this. So our program has launched in 2021. We accept one admission per year. So the next cohort will start in September 2022, just in 3 months. This program is completely online, and we hold all lectures, webinars, exams, term papers, etc. only in English. So be ready to speak English and to prepare your tasks and exams in English. You will study 16 courses, and you will also study 2 courses in parallel. Actually, it's quite difficult, and you need to estimate your time. Um, we have 6 industrial partners. Olga today presents one of them, Huawei company. Others you may see at this presentation. What about next stages? You are welcome to apply to our program till August 10th. This is the last day when you can apply your application and to try to register to our program. I'd like to mention that application, registration, entrance exam is free. You haven't pay money for this. Next step is entrance exam. So first you register for our program. Second, you pass entrance exam. The closest entrance exam day is 23rd of June. It will be Thursday next week, yes. And the next one is August 17. Only 2 exam sessions. You may pass exam only once, and you will offer to solve 4 problems, 3 mathematics tasks and 1 programming. The examples of exam paper you may find out on our official website. You'll have 120 minutes. Also, I'd like to mention that you may just try to pass the entrance exam, and that's not obliged you to enter our program finally. You may just pass entrance exam, and after you have time to think, will you complete your application, or you just stop here and will take 1 year more to think about this. And payment, it's very important that before enrollment, to be enrolled to our program, you have to execute at least first payment and not later than August 25th. I think that's all. I also see question in chat, yeah? Slide, please. Sergey, which slide would you like?
I think he mentioned that you when you spoke, you didn't take next slide. So you was hold it on the first slide only. You were
Really?
showing only yes. I think you have to put F5 key and to show your presentation probably again. I don't know, but we couldn't see any useful
Oh, why,
links.
why didn't you
Yes,
tell me
yes,
before?
okay.
Now, do you see my presentation?
Yes, I see your presentation,
First slide,
but
yes, about MCU
yes,
program.
only first. Yes.
And now, the second
Yes, and
one.
this is the second one. Yes, I see QR
Have you
code.
seen, have you seen it before?
No,
Um,
I just seen it on the preview on the left side. I think
okay.
you have to go to the present mode of the PowerPoint.
This one?
And
Yeah? Do you see my first screen of presentation about MC?
no, I think it is a problem of PowerPoint. Probably you have to manually switch your slides.
Okay, that's actually not a problem. Sergey, could you please ask by voice or type the particular question? What exactly are you interested in? An entrance exam or a process of application or what? That will be more effective. Like if I have some problems with my PowerPoint, I can. I did some action and I invite you to participate in our webinar as an administrator.
You mean me?
No, I actually speaking to Sergey. I don't know. I'm not sure
Okay.
if he uh, listened to me. Message in chat, yes.
Okay.
Voiced by you, thank you. It was voiced by you. Okay, actually, all information has placed on our official website, and I also copy all information in our Telegram official channel by request, without request, up to you. And the last one information which I'd like to mention that our first cohort students, which has started last year, by today, almost completed their first year of study. And last week we organized Students Project Defense, where they presented their projects in machine learning and computer vision. And actually that was really very interesting and almost the same like Olga today presented for us. And I'd like to show, to Olga maybe mainly, show smart 3 seconds part from that defense. I'll try to do this, but not sure how it works. Do you see my screen YouTube channel?
Yes.
Yeah. So we have international group. Some of our students are from China, from Vietnam, Saudi Arabia, and others. Actually, I don't remember the full list. And this was student from China, and he presented the application to maybe object recognition. I'm not sure how is it called. I'll start the video. If it doesn't work, please let me know, okay?
Okay.
Using the mobile net V2.
It works.
It works, nice.
So this is
short comment that at this project defense, students first of all presented their results using the presentation, and at the end they demonstrated short video just to prove that the application works correctly.
so this is here's a selfie of many people faces, and here's the result with frames of faces and the probability of being a human face, and also some other interesting example that I found. You see this image, the left edges, the left boundary is cut off into half, but actually the it still can be detected. So I think it's a really powerful network. And another one, even a cartoon face character's face could be detected.
Okay, actually that's all. I just wanted to demonstrate that even first year students demonstrated their results by the end of first year, and there were different projects. So I think that's all for today. Yeah. Thank you, Olga, for joining us once again. Thank you for such clear understanding information. And I'd like to ask if you can share your presentation maybe in PDF format or no for our.
Okay.
Okay.
Okay. I can share with you it, but I think in video in the PDF will be just just a picture. Okay.
And it's up to you which
Just a slice
format
of
you
video
choose.
in PDF. Okay.
Okay, and question of Daniel Sergey, could you share the link with Defense Record, please? Actually, I'm not sure. I will check this moment if we are able to share such videos, because it was internal event of HCE Defense, and I'm not sure that I can do this. But if I can, I will share it to you in Telegram channel. That's all. Thank you for attending. Have a nice evening. Goodbye.
Thank you all. Bye.